Hello. Good morning, everyone. I hope everybody's doing good. Thank you for joining our Code Talk today. Today, let's see how member-owned financials can use Agentic AI to improve their member experience. I am Murali Ramanathan, Senior Solutions Architect, AWS.
I'm Mrid Balasubramanian. I'm a Principal Solutions Architect. We work with AWS not-for-profit financials. So how many of you here are from member-owned financials? Awesome. Is that credit unions, insurance? So how many credit unions? Just one. How about insurance? Awesome. You guys outnumber.
Yeah.
Any other member-owned? Which one is that?
Royal Bank of Canada. Oh,
awesome.
Nice.
Okay, cool. Welcome all.
Welcome.
You're definitely hardcore if you're showing up for the very first session of reInvent. Hopefully, we can get you off to a great start and get you a lot of value out of this session for your time.
All right.
So off to you.
Yeah, in today's session, let's see the art of possible, where we will be showing how we can use Agentic AI for loan origination system, and which will have the member-owned financials process loan applications in a much quicker manner, thereby increasing member satisfaction and experience as well. And this solution we are going to show today is built on AWS Agent Core, for which Mridula is going to talk about the features of it.
Awesome. So how many of you here have heard of Amazon Bedrock Agent Core? Awesome. And have you actually tried working with it? Okay, not yet. Okay, so you're in a good place. So the idea for the Code Talk today is to demonstrate a completely working end-to-end solution that was built using AWS Strands agents. Anybody heard of Strands? Awesome. Anybody using other frameworks, agentic frameworks? You can just call it out. Autogen. Okay. Anybody? LangGraph, Crew AI?
LangGraph.
Okay. Yep, there you go. So no matter which agentic framework you work with, and we are very aware there are many of them, and there are probably more coming. Agent Core, which is kind of it was launched last reInvent and became generally available mid-October. So this is essentially a comprehensive agentic platform on which, so the solution that we're going to be showing you today, this is the agentic loan origination system that many of you in credit unions and banks can relate to. This is just an example of, but it's a enterprise-grade production, almost production-ready solution that was built using Strands agents and then deployed to Agent Core. So before we get into the architecture, we want to kind of give you let's get the basics out of the way, right? What is Agent Core, so that when we go into the code and show you how it works, you know exactly what it does. So Bedrock Agent Core, like I said, it's a comprehensive agentic platform where you can essentially deploy and manage your agents. It's agnostic to the models that you use for building your agents. It's agnostic to the frameworks that you use for building those agents as well. Has a few key components, which I'll go through quickly. There's Agent Core Runtime, which is essentially the serverless component. It's the compute, where you deploy your agents as container applications. And then you have agent memory. So especially with agents, you might start off with a single agent. You might grow into multiple agents. You could have multi-agent collaborations. So the idea is that you have a managed memory component that you can associate with your agent. And this can be either short-term memory that enables those multi-turn conversations, but also if you're working with multiple agents, you can have longer-term memory as well, because this then spans multiple sessions across multiple agents. So agent memory code is essentially that capability of bringing that short-term memory as well as long-term memory to your agent applications. And then another piece that we're going to be talking about and that we used in our solution is Agent Core Gateway. How many of you have heard of MCP? Does that ring a bell? Awesome. You want to call out what it stands for? Awesome.
Awesome.
Yeah. So Agent Core supports these open source protocols, definitely Model Context Protocol, MCP. And that's really where Agent Core Gateway shines. That's essentially your managed MCP server that you can use as kind of that unified interface that your agents can communicate with tools that are set up as targets behind those that Agent Core Gateway. And you can have, you might have existing APIs in your organization. You could have, other applications which you might make an API call to using a serverless compute like Lambda. So essentially, you can have a Lambda function running as an MCP tool behind that gateway. You can have your existing APIs. So it supports open API schema or Smithy models on the backend. So all of those existing resources can essentially be MCP-fied, if I might use that, behind that gateway. So that's really what that is. It's that MCP interface. So we're going to be talking about that as well. So we covered agent runtime, which is the compute, the gateway, which is that managed MCP server, and then the memory, and then there's the identity piece. So any enterprise-grade application definitely requires end-to-end authentication authorization, right? And that Agent Core Identity is that agent-managed identities service. It centrally manages the inbound and outbound auth. What that means is, as you have your users' applications that are accessing an agent, and the agent is making calls to all those tools, or in our case, we actually have A2A. So agent-to-agent communication is what we're going to be using in our multi-agent collaboration application that we're going to show you. That inbound and outbound auth is centrally managed by Agent Core Identity, which is seamlessly integrated with the compute, which is the runtime. So all of those different pieces coming together to help you build a scalable, secure, enterprise-grade agentic application. So over to you.
Thank you, Mridula. And that was great explanation. I wanted to add a couple of more things. You are also seeing something called as Agent Core Browser and Agent Core Interpreter. These are the tools Agent Core offers. Agent Core Browser gives you the ability for the agents to browse websites on your behalf, then get the results and process them. Agent Core Interpreter gives you the ability for the agents to run create and run complex code at the runtime itself. What that means is you need not write code which an agent needs to call and maintain that code. You can just define and say what code you want the agent to create and run. The agent will do that. We will see in the example now.
Yeah, so one other thing that I want to add quickly is, typically with agents and agentic applications, right, you tend to think of them as black boxes. So visibility, into what those agents are doing, that observability aspect, right? So the three pillars of observability, the logs, the metrics, the traces, all of those are super important so that you can trust the system that you build. And that's where Agent Core Observability comes in. It supports OTel, so that's your open telemetry, and it's integrated with AWS CloudWatch, if you're familiar with that. So you can essentially see at the session level, at the trace level, as well as the spans. So the granular, very fine, the granular aspects of your entire trace, end-to-end request flow and the response flow of your agentic systems. All of those can be seen and dashboarded using the OTel logs and metrics that come out of Agent Core Observability. So I want to point that out because that's a big piece of putting these agentic systems into production. So
Awesome.
Yes. It's a first-party tool.
It's a first-party tool. Awesome. Now I'll walk you through the architecture of the solution we built. Then we'll show a demo, and then we'll walk you through the code of the agents as well. Now here you're seeing the architecture of the loan origination system we built using Agentic AI. Let me walk you through that from left to right. On the left, you would see the document upload, where an applicant uploads all of the documents needed for processing the loan. As soon as those documents are uploaded, they come and land on an NS3 bucket. And once they land on an NS3 bucket, a Lambda event fires off and then calls what we call as the supervisor agent. Then the supervisory agent here is tasked with the role of saying, you are a supervisor agent who will be processing loan applications. And one of the tasks the supervisor agent would have is it has to find out what other agents are there which can work along with the supervisor agent to perform this loan application process workflow and then work with them to get the whole task done. The supervisor agent then, using the A2A protocol, reads the agent cards of all of the available agents and then finds out that there are 3 agents it can work with: the document agent, the credit risk agent, and the compliance agent. Once it decides what agents it can work with, then it creates a workflow, and then as an action item, it calls the document agent with the information of where the documents are located. Now the document agent, whose role is to validate the documents and also extract the information from the documents, knows that it can validate the information, but it does not have the data extraction capability. Then again, using A2A protocol, it reads the agent cards of all the other agents and finds out which agent has the document extraction capability, and that's the Bedrock Data Automation agent here, and then passes that information to that agent. Then that agent is being tasked with the role of saying, you are only to extract information from documents using whatever tools are available to you. Now this document agent, extraction agent, then uses the agent core gateway and does a semantic search of seeing what tools it can use to extract data from the documents. Then it sees that it has access to Bedrock Data Automation, and Bedrock Data Automation is the AWS service which extracts data from documents, images in an intelligent way using AI. Now here we are showing the art of the possible, where the Bedrock Data Automation agent is accessing the BDA or the Bedrock Data Automation using Agent Core Gateway, which is simulating an MCP what you would have. So in a real world scenario, you may not even have a Bedrock Data Automation agent. You may have your own data extraction software running and the agent which is connected to the Agent Core Gateway as an MCP server, and your Bedrock Data Automation agent will automatically connect to it for data extraction. Once the data is extracted, then it gives it back to the document agent, and the document agent then performs all the validation to ensure that all of the data needed for processing the loan is there. Once it performs a validation, it gives a status check back to the supervisor agent along with the data saying the data validation is passed or failed. The supervisor agent, as part of the workflow it built, it then decides if the data validation is passed, then it will send it further down to the credit risk agent and the compliance agent for further processing. But if the data is not there, using the code interpreter tool as a tool, it will again send an email back to the applicant saying there is information missing from your loan application. Please provide all of this information for processing the loan application further. Once all of the information is validated, then the supervisor agent, as part of its workflow, then will, using A2A protocol, then gives the information to the credit risk agent and the compliance agent for credit risk processing and compliance checking as well. Now here, the credit risk agent, using the code interpreter as a tool, it calls the credit risk machine learning model, which does the actual credit risk assessment. In this demonstration, this ML model is stored in an NS3 bucket that the agent builds code on the fly using code interpreter to download it and then interact with it to perform the credit risk assessment. In a real world scenario, you would be using the code interpreter to actually call a SageMaker endpoint or wherever your ML model is and interact with it to perform the credit risk assessment. And the same way, the compliance agent, using the code interpreter tool, builds code on the fly to perform the compliance agent checks and then passes all the information back to the supervisor agent. The supervisor agent then gets all of this information and then uses its decision logic, which we have provided in the prompt as a standard operating procedure for the supervisor agent, and then decides to either approve the loan or put it under manual review or disapprove the loan. Once it performs that decision, then using the code interpreter again and using Amazon Simple Email Service, it sends an email to the applicant informing the status, and also it creates a PDF document of what the loan application was, all of the details, and uploads it to an S3 bucket so that the underwriter can review that document and then perform the final decisioning as well. So this way, with this solution, we are making the underwriter's job very easy. We are making sure when the underwriter, when he has the information, he has all the right information and he can quickly assess that information and whether approve or disapprove the loan based on the criteria. Now let's go ahead and see a demonstration of this solution, and then we'll walk you through the code, how we built that.
I'll switch the demo.
Yeah, just give me a second.
Yes.
So when you have the credit risk ML model, this is something can you also implement with the MCP, because what is the feature engineering that is to be done? How does it arise here? How does the agent decide that what features it has to extract for this ML model?
So in this case, we are using the MCP, the model for just simply inference purposes, right? So we're not actually training or feature engineering data to build the model. So in this case, it's already a built model that's been deployed.
We expect some features, right?
Yes, yes. So
How does the agent know that what features to extract and when to?
Yeah, that's a good question. So basically, you can have your own model as an MCP server, and in the document, in the credit risk assessments agent's prompt, you would define there as a standard operating procedure, like what features you would be need to passing on, what features you would be expecting it. Using that, it will build the code and then interact with the model.
yeah, so as you set that up, I can clarify further. Prior to getting into the credit risk evaluation, right, or creditworthiness check, before that, there is another agent in the workflow, which is the data extraction. So in the demo, you'll see, if you're ready, you can just go ahead with that.
Yeah.
And I'll explain to you more.
So here, I'm playing now, and I'm playing the role of an applicant where, I'll be uploading the documents. And because this is a demonstration, we are not going the process of, using a chat window and uploading all the information, as that will take time. So I'm uploading the loan application, I'm uploading the pay stub, bank statement, employee verification, tax returns, and all of these are demo data, by the way. And I have now uploaded the my loan application as an applicant. Now let's see what happens in the backend. Now we are using, as Mrudula explained, using agent core observability. From the logs, we would be seeing how the agents are processing the information. Now we are seeing that the supervisor agent is discovered all of those specialized agents, and then it is starting the workflow by sending the document to the document agent for verification. Then the document agent then knows that it has to verify and extract the data. Now it is searching for what are the agents which can do the document extraction. Then it found the right agent, which is the document extraction agent. Then it gave that information to the document extraction agent, and the document extraction agent now is using a tool to communicate with the Bedrock data automation to extract data. It will take a minute or so for the data extraction to come back.
And I want to add that all of this is being done using A2A protocol. So that's the design pattern that we chose for this particular solution, because it gives us the most flexibility in terms of demonstrating at an enterprise grade where you have
Sorry to interrupt you, Mridula.
Yeah, go ahead.
The document agent came back with the response.
Perfect.
And now the document validation agent would now take that process back, and now it will be performing the validation. Sorry, go ahead, Mridula.
Yeah, no, I was saying that A2A is really good when you have, you might have a handful of agents now using a few tools, but then, as you start adopting, building more, you could be buying, you could be building agents. So you soon might have a lot of different agents using a lot of different tools, right? So like N tools using M number of N agents using M number of tools. So it really becomes a huge matrix. So A2A helps you because it's doing the work for you in terms of discovering the agents that are already in your enterprise using an open protocol, agent to agent, right?
Yep.
So that's the one we chose.
Yep. Now the document has validated, and it is passing all of this information back to the supervisor agent, and the supervisor agent now has seen all of that information and is now passing it to the credit risk or to the compliance agent in parallel. Again, as you would see from the code, here we are not defining here for any agents like the supervisor agent or the document agent. You should use that particular agent. It is able to decide on its own using the workflow which agent it has to use for the processing. Now you would see here the compliance agent has been done, and the credit risk agent, it's now processing it using the code interpreter. You would see that it is downloading the model from the S3, then it's interacting with the model to perform the credit risk assessment. Again, all of this, it's building the code on the fly and then executing it.
Yep, and while we are on the credit risk, to answer your question, so once the data has been extracted from the forms, you now have the information that you need to send in the request to the model, right? So those are the features, and those are all based on prompt. Yeah.
Here, the credit risk has responded that the ML model predicts a 98% probability of a successful loan repayment. Now the supervisor agent has got all of this information. Now it's processing its decision logic to say whether should I approve the loan or not, disapprove the loan. Any questions? I know it may be a lot to take in, but if you have any questions, please let us know.
Yes.
Do you have thresholds set on BDA where you're saying confidence score level needs to be a certain level before it's passed back to the agent?
Yeah, you certainly can do that. I think we're using some default thresholds on the back end, but BDA, if we keep calling it BDA, but it's actually Amazon Bedrock Data Automation. It's a feature of Bedrock, and this is a capability where you can essentially extract data using your custom blueprints. So in this case, like Murali was showing, we have we used 5 different documents that are pertinent to a loan application, right? But you could have, using Bedrock Data Automation, you can essentially work with multimodal data. So that can be text, images, video, what have you. And then you can specify blueprints, which is essentially the schema for kind of the overlay on your data so that you extract only the specific fields that you care about. And then because it's AI powered, it's going to come back with explainability in terms of the probability for essentially the accuracy of extracting that information. So you can then use your business rules to decide what the threshold should be. And that's also a good, that threshold is how the criteria that you would set to maybe incorporate a human in the loop. If you feel that it's, below the threshold and, And typically something for like credit decisioning, you do want to have a human in the loop, right? Because especially if it's a deny, not an approve, you want to make sure your loan officer takes a good look at it, looks at the probabilities of the information that was extracted, and use that kind of as the basis to see why it was approved or denied. That makes sense.
Yeah, and here you see that the supervisor agent has completed the workflow and it has given a final decision of approve, and it's showing all of the workflow summary. Now, all of these you are seeing is on the observability, which is on the CloudWatch logs. So anytime you want to check, trace back what happened for a particular application, what were the steps the agents took, how did they arrive at the decision, all of them are there for audit purposes, and you can ensure that the right decisions are being made all the time. Now let's look at the PDF it has generated. So this is the PDF it generated. Again, we will walk through the code now. We just prompted in the prompt of the supervisor agent, we said create a PDF with all of these details, and it automatically created all of these. It gives all of the information for the underwriter, like what is the credit risk assessment, what's the compliant validation, what are the next steps, all of those things it will be there in the PDF, and the underwriter can use this to make their decisions very quickly. Now, any questions on the solution? Go ahead, please.
How do you guys prevent prompt injection for the upload documents? How do you ensure that those documents don't have any sort of injected prompts in them to attack your model?
That's a good question. So as Mrudula explained earlier, all of these agents use A2A protocol, and all of them use OAuth authentication. So within the OAuth authentication, when these agents want to communicate with each other, only if they have the right token, they would be able to communicate and access those functionalities. Any other external, if some other agent wants to interact with these agents, as you said, to do a prompt injection, that would not be possible.
So I'll add to that. That's because that's a very important question. We haven't used that in this specific solution per se, but this is what you can do to make sure that you don't have issues with prompt injection or any other, any of the OWASP, agentic AI risks and how to mitigate them, right? So on that vein, so Strands agents is the one that we are using here that supports guardrails. So if you're familiar with Amazon Bedrock guardrails, it's essentially a capability where you can specify like automated reasoning checks, grounded checks, denied topics, which is more around the question that's being asked, moderate content, things like that, right? All of those filters can be something that you can associate with the guardrail, and that guardrail itself can be associated with the model that is used in the definition of your agent. So as we go into the code, I can show you the exact lines of code where you can associate a guardrailed model in the agent itself. So that is supported.
Awesome.
Yes.
There's a lot of numbers here that are needing to be very accurate. How are you passing that from the extraction to all, and several agents in the way with several different calls? How are you ensuring that the data that's extracted is what the models are seeing from each of those individual calls? Is that some stored memory somewhere, or like how are you actually relying or making sure that those numbers are accurate by the time it gets to the supervisor agent?
Yeah, great question. And I think that also leads into kind of the auditability of this solution, right? Yeah. So when we talked about the Bedrock data automation, the BDA tool, which is the one, the workhorse that's actually looking at the documents, extracting the information, giving you the probabilities for all of that. All of that data, extracted data, gets persisted inside object store, S3. So long after the process is done, that data is still there for you to look at anytime by your regulators, your compliance officers, anybody. And that then becomes the source So the agents are simply just doing the kind of the back and forth of orchestration. They encapsulate your business logic, but the data itself is persisting in that object store. Yeah.
Now let's look at how we build this solution. And one of the first things I want to mention is we built all of the solution using Kiro or Agentic IDE. So using Kiro, we worked with Kiro. You can call Kiro as one of our members. It helped us build out this whole solution in a very quick manner.
So shall I do the specs?
Yep.
How many of you have played with Kiro before? Have you even heard of it? Okay.
Just give me a second. So let me.
Yeah. So this is our latest agentic coding tool. It's Agentic AI IDE, essentially standalone. It's built from the ground up. It's not a plugin into any IDE like Q Developer you might have heard of. This is kind of a standalone IDE. And it's really good at spec-driven development. So we used the IDE for developing this. I wanted to show you the spec-driven development pretty briefly. Let's see. Okay. So unlike vibe coding, any vibe coders here? Everybody? No vibe coders? Okay, I thought, if you didn't raise a hand, that means everybody's a vibe coder. No worries. So Kiro supports vibe coding, but we are not just looking at POCs, right? We are looking at how do you build an enterprise-grade application. So we're following a very rigorous process of using spec-driven development. And what I'm showing you here are the assets of that, essentially your requirements, your design, and your tasks, so you can implement the solution. So part of the requirements, it's essentially the entire SDLC, right? Starting with what are your user stories and what are the requirements associated with each of those. So like we mentioned, we wanted to use the A2A protocol. That was our starting point. That was one of our main requirements. So as a systems architect, I want all my agents to communicate using this protocol. So, a lot of requirements there. Agent discovery, again, this is based on Strands supports this, Agent Core supports this, using agent cards. And then there's quite a bit. It's pretty comprehensive. But just for each of the agents themselves, they have very specific requirements. Like the BDA agent has its own set of acceptance criteria, and so on. And then going into the design, the idea is, measure twice, cut once, right? Make sure you come up with, the way we did this was we used Kiro, gave a kind of a brief description of the problem that we were solving, and Kiro came up with, all of these assets, right? The requirements, design, and task. But that's just a first draft. It's a pretty iterative process. So you can review what it comes up with, then you can modify using your natural language prompts. So continue to refine the design until you get to a state where this feels like it's pretty close to your use case. And that's exactly what we did. So it comes up with kind of the as-built architecture, the loan request coming to the supervisor agent, which is then communicating using A2A with all the specialized agents. So lots of information when you work through this in terms of what the design should be, and then into the tasks. So these are tasks that you would, it's doing the tasks in a phased manner, starting with the infrastructure setup. So this is infrastructure beyond just Agent Core. These are, basic things like setting up your S3 buckets, right, which is where your input data, so all your loan application forms, all of those get stored, as well as the data that's extracted by data automation, that gets persisted as well. So getting all those buckets set up, getting your OAuth set up. So in our case, we used Amazon Cognito for that. You might have your own IDP that you want to integrate with, right, like Okta or Entra ID and so on. So getting that OAuth set up is another piece of getting ready to build the solution. The other things are too is how do you store your secrets, right? Like secrets manager, that's a very important one. And then your IAM roles, right? Your permissions that each of your agents would have to interact with other AWS services. Then things like Amazon Bedrock gateway, agent core gateway that I mentioned. So that needs to get set up so that you can then, the agents can then access the tools that are targets behind that agent core gateway. So some of that infrastructure needs to be done upfront, so that's phase one. And then phase two is essentially building all of your agents and then deploying them to agent core runtime, which is your compute. So, a complete set of tasks which then get checked off as Kiro starts implementing your solution. So just a structured approach to having an end-to-end solution.
Awesome. So now let me walk you through how we build the supervisor agent. So all of these agents, we'll be explaining them, basically we're breaking down into 4 sections. The first section is, what are libraries you need to import. Here, we are saying, you need to import the Strands multi-agent A2A from A2A servers that enables the A2A communication. Then you also need to import the A2A client and from the client tool provider so that it is able to discover the agents. Then we are also importing the code interpreter so that you can provide the code interpreter as a tool to the agents. And the other 2 libraries are making sure, those are required for running the A2A agent as servers. Then we have the configuration section where we configure, what's our AWS region, what are the buckets we are using, any other parameters we are using. And we are also have a code, and this is only bit of the code you would see in all of this, where, how we are handling the OAuth tokens between the agents. When this agent needs to communicate to another agent, they need to have the refreshed OAuth token, and this part of the code would handle that. Again, here, as Mridula mentioned, for the client ID, client secret, token URL used for OAuth tokens, we retrieve all of them from the secrets manager to make sure they are not exposed as well. And this would be the main part of the supervisor agent, which is the prompt. In the prompt, we define what is the role of the agent, what task it's going to be doing. Then we are going to also define how we are going to be discovering the other available agents, what kind of tools you would be accessing to discover the other agents. Then we'll also be defining, like as a standard operating procedure, when you are selecting another agents, what are the qualities you need to look for in those agents when you want to pass on the tasks to them. As an example, if you want to use an agent for document validation, then you need to ensure that, when you read the agent card, it has words like document, validation, compliance, completeness, etc. in their agent card. So only use those agents for document validation. So here we are making sure we are guiding the agents to make sure they perform the way we intend to. Then we are also making sure how agent communication, as many of you ask questions, right? How does agent know, what data comes back and forth, how they would be interacting with other, as an example, an ML model. This is where we define, what is the type of output you would be expecting, what is the type of output you should be sending to other agents. We would be defining all of these things here. And then specifically for credit risk assessment, what you should make sure, like one of the things we are ensuring that, you are passing the entire validated data structure to the credit risk assessment, so that whatever agent is performing the credit risk assessment, it has got all of the data. Do not just truncate some of the data and pass it across. So these are the instructions we provide to the agent. And finally, we also provide the decision logic, how it has to say if a loan application is approved or manual review or rejected, what is the decision logic it needs to follow. Then after completing it, we are saying, once you create your, you have your decision, then use the tool to make a PDF report, and we are just specifying what information must be there in the PDF report. And what are the PDF report requirements we are specifying. Then we are saying upload it to an NS3 bucket. We are saying, which bucket you should need to upload it to. Then we are saying, where you should send an email to. Because this is a demonstration system we built out, we made sure that, all of the emails go to just one email address. But in a real world scenario, you can specify that pick up the email address from the loan application or from the conversation you had with the applicant, then send that response back to that email. It would go ahead and do that. And you would also want to say, how you want your email to look like, what is the formatting, all of those. Now, again, one of the key advantages of this is if tomorrow, if requirement changes, all you would have to do is come back and change the prompt, and which is very easy to do, because this is more like natural language, where you define in your own natural language saying what you want the agent to do, rather than having it as written as a code and maintaining the code. Just come and change the prompt here. It can quickly adapt to your changing business requirements.
Sorry, one question. Mm-hmm. How you are the dependency of the output of this one? Let's say you run the model one more time based on this prompt that you provided already, right? If the outcome also is the same for the next time around, maybe the first one is like this, but is there any guarantee deterministic that the output for the second one is the same?
Yep. So you're basically bringing out the non-deterministic nature of these agents, right? However, in this case, if provided in this case your inputs are still the same, right? It's the same set of documents, and the logic inside each of these agents, like for example, the calculation of creditworthiness, right? Whatever business logic you have inside the credit risk agent, for example. Those are still pretty deterministic because those are just mathematical calculations. So the agents themselves it's not like a text-based prediction. Yes, you're using a lot of prompts to drive the work, but you are under the hood in those prompts being very specific. And this is where, like we were mentioning, the SOPs, the operating procedures come into play, right? As long as you have that clearly defined in the prompts, the calculations will follow, and then the results of those are still deterministic. And so the input stays the same, the data extracted stays the same, and as long as the, even with like the data BDA tool that you're using for extracting data from each of those documents, if you're still keeping that same threshold, the data that's input into those downstream mathematical calculations still is the same, right? So you should not see, for example, something flip from an approval to a denial kind of a thing.
And as a best practice, yeah, go ahead, please.
So
yep.
This particular supervisor problem that you're showing, right? What I'm seeing here is 99% of this is all requirements, analysis requirements. So how do you expect this solution to be working? Like typical business requirement, and ADI calculation that says, oh, today I'm taking 3% of the credit card instead of what percent going? That's my mistake, right? That's a business requirement change. How would that come into play?
So if I understand your question right, today you may have a DTI requirement, tomorrow you have another DTI requirement, how you would want to adapt that. As you know, all you can go ahead is, can change in your system prompt, how would you want the decisioning logic to be done based on the DTI.
How do you do the DTI calculation? I don't see a DTI calculation in this.
Yeah.
That's a business requirement. What I'm trying to get to is
Yes.
business requirement. It's great for part of it as an engineer. It's great that I know the results, right? But I'm not seeing a lot of business requirement in this.
Yeah, so the DTA prompts, that is not how it calculates the DTA. That is in the compliance validation agent. That's where it is calculating the DTA using the code interpreter. There you can define, how you want the DTA to be calculated. The supervisor agent, in this, the supervisor agent is just playing the role of an orchestrator, where it is passing information to all of these other agents who have their tasks clearly defined. As you said, for the DTI agent, it will be the compliance agent, where you will have the prompt defining how you are calculating the DTI using the code interpreter, and there you can define your thresholds there.
Yeah, I think we haven't shown that piece yet, but there's a specialized agent and the prompt which captures that. Yeah. Yes.
So in designing a system like this, how do you recommend evaluating model accuracy between the different models if you were to switch out for, let's say, a newer model?
That's a good question. In Bedrock, we have we have something called as model evaluation, where before you start building these solutions, you can start evaluating a model. There are two types of model evaluations we offer. One is we have curated data sets, where you use those curated data sets to have the model run against them, and you can see the accuracy. Or you can bring in your own data and use it against those models to see which one works best, and then use it in your system as well.
So basically, it requires you to have some kind of ground truth data, right? Something that you have historically for similar profiles of customers, what the loan decisioning has been, right? And then there's definitely a lot of work involved. You need to set up that evaluation harness on your end, so that when you deploy these kinds of systems, you have something, some kind of a gold standard to compare to the results that are coming out of it. Because, and that we can't, emphasize enough the importance of testing, especially with these non-deterministic applications.
Is that framework something that you would build into this application, or you would run separately?
So we have, I haven't gone through, the entire task list, but in the design itself, some of the aspects of that design include testing. That's end-to-end testing, so that includes unit testing, integration testing, all of that. And if you have specific evaluation, like metrics and things like that, and a source of data that you can point to, all of that can be incorporated as well.
Have you used any agentic pattern to ground the agents, like reflection? How do you use it?
Like design patterns. So we are in this case using the Strands A2A design pattern. It's pretty standard. Strands also supports others like workflow, which are more deterministic. The graph-based design, a graph as in each of these specialized agents can be nodes. And they, you can have essentially like in a graph, right? You can have edges connect between, if you think of each of the agents as being a node, the communication between them is an edge, right? So you can define what that multi-agent structure needs to look like in a graph. So that is one of the other design patterns that's supported natively by Strands agents. A2A it's a more flexible based on agent discovery that we're using, but this is one of the design patterns that's supported inside Strands framework as well.
Reflection, basically.
Yep.
That all is already handled within agents, or we have to separately define it?
Like the React pattern, right?
Yeah, React or reflection.
Yep.
These use the React part where they do
Yep.
the reasoning and an actioning of it, where they reason that, given I have this task of, as a supervisor agent, this task is I have to process these loan applications, and I have a set of tools to me, and they use a reasoning to create a workflow, then use the available tools, the agents, and the code interpreter to perform the tasks.
Yeah.
Inbuilt in Strands?
Yes.
So I think the best way to get to your question is so reflection, right? So this is based on the model capability as well. In this case, the model that we are using is Anthropic's Claude Sonnet 4.5, which is very capable of reflection. So it's built into, so that's the brains behind each of these agents. As newer models come along, right, that can support even more advanced reflection or additional patterns, you can have, like I was saying, these agent core strands, they're all model agnostic, right? Each agent can, essentially, you can use a Bedrock model, or you can use an open source model, and each agent can use a different model. It doesn't have to be the same model. So it's inbuilt into the agent itself based on the model selection.
That's a good segue. The last fourth section, which we wanted to show in the code is, after the prompts is, how we are defining the agent here. If you're looking at here, we define the agent, what is the name of the agent, the description of the agent, the system prompt, which is the system prompt we saw in detail, and as Mridula mentioned, the model, which is agnostic again. You can choose what model works best for you, and you can have that model here. And the tools are all the tools like agent discovery and the code interpreter tools. And finally, we have the agent running as an A2A server. So that way, each of these agents, they use A2A communication to between them whenever they want to communicate. The advantage of using an A2A communication is tomorrow you may have another agents which is not running on agent core, but still using A2A communications. These agents running on agent core can communicate with them as well.
Yes. The data that's passed between the agents. Yeah, so in this case, since we're using A2A, it's a JSON RPC message format. And so this is the output of one agent gets passed in that format, the JSON RPC format, to the agent, like the supervisor agent, for example. So that message body contains all the information that's basically the input that's needed by the next agent.
All of these agents uses HTTPS protocol. So
Yep.
all of those, whenever they are communicating between them, even when they are communicating this JSON data between them, they are all encrypted.
Yeah, and there is on that OAuth happening every step of the way, right? So the OAuth setup that we used, at the beginning that I was talking about using Cognito, you're using. So yeah, this is a very important piece that we probably haven't mentioned yet. Is when you deploy your agent, you configure the auth configuration for each of those agents. So you can have something like IAM SIGV4, if you're familiar with that, that's the default, but it also supports OAuth 2.0. So in this case, every agent that we deploy, there is a configuration that needs to happen, and we set that up as like a JWT custom token. So every single one of those agent interactions is authenticated and authorized. Yeah.
I think you had one question. We'll take. Yes.
So every node is going to basically process in its own session, right?
Mm-hmm. Correct. Yes.
So with the data across the different sessions of that meeting.
No. Correct.
Is there a artifact control at the local tool level?
So RBAC control, you said?
Within the local tools, whatever the agent is using in terms of tools.
So these are tools behind the gateway? Are you referring to the tools behind the gateway? Yes. So the agent itself, right? So in this case, for example, the BDA agent, the data extraction agent, that's actually calling making that we set up what is called an MCP client on the agent. So the agent is acting as your MCP client, and then it's communicating with the agent core gateway, which is that MCP server, right? And behind that, you have essentially a Lambda that's making an API call to Bedrock BDA, right? So the communication between the MCP client and gateway it's an OAuth 2 authentication and authorization as well. And then behind that, it's all IAM permissions. So that's where RBAC comes in. Yeah. Yes.
Here you have mentioned like all the tools in the single agent. So I have experience like if we provide more than like 40 tools or something, agent get starting confusing like between choosing each of the tools.
Correct.
How do you like avoid?
Yeah. You want to talk about the semantic search?
Yes. So one of the ones we have in agent gateway is what we call as a semantic search. And as you said, right, giving agent more than 40 tools, and it does not decide, what tools to use. There are two things. One is making sure our prompt is very clear of what our requirements are, so that it specifically knows what the task it has got, and then it can search the right tool. And in Agent Core Gateway supports something called as a semantic search. In this case, when we say the BDA, when the Bedrock Data Automation Agent, when it has to do a data extraction, it first does a semantic search, like data extraction. What tools are there available for data extraction? And then the gateway returns available tools which are there for data extraction. Then it chooses that and performs the data extractions. In your case, if you have got more than 40 tools, you can have it behind a gateway, Agent Core Gateway, and then the agent can do a semantic search based on the task, what it wants. Then the Agent Core Gateway will return maybe out of 40 tools, maybe 10 tools. And then out of those 10 tools, the agent core is then agent is able to select the right tool to perform the task.
Yeah, and I'll add that, really the best practice is, you want to think of the agent as being a microservice, right? Essentially that same mindset. So depending on, it's definitely purpose built for that business function, right? So you want to give it the tools only that it needs and only the permissions that it needs for those tools, right? So you don't want to have 40 tools, for example. The specialized agents especially should only have, like a couple of tools, 2-3 tools that it really needs to get the job done, right? In the supervisor agent, this is like accumulating, because it's trying to help the specialized agents figure out which tools to use. It's listing them, but the supervisor agent itself is not really calling those tools. So it's different, right? So, but yes, that's a very good point. You need to have purpose-built agents and just the tools that they need.
We just have 1.5 minutes left,
Yep,
so I'll just walk through one more agent, and any other questions, we are available outside the room to take them as well.
Actually, we can just wrap and go to the...
I just wanted to quickly, showcase the compliance agent, the prompt, and show, how it is doing the debt to income ratio. You would see in the prompt here, it's using the code interpreter to perform these. And tomorrow, if your business requirement changes, you can come here and change it in the prompt itself. It's not the supervisor agent which is doing that. Here we have purpose-built agents for each of these functions. And when you want to change any of these functions, you can come to those purpose-built agents and change the prompt there, and your newer business logic would come into play.
And do you want to show them the code that they can go to? We want to give you something actionable so that, as you walk out of the room today, you have something to go build. So we have a couple of official repos. One is the Strands agents itself, which contains, it's a GitHub repo that contains all the different design patterns that you can build with. A2A is one of them that we used for today's solution. And then another official GitHub repo for Bedrock Agent Core. It's a really rich set of code samples. We based a lot of our solution based on those code samples that are in Bedrock Agent Core repo. So please use those. They just accelerate your entire development process, right? These are vetted solutions meant for building secure, scalable agentic AI application. So go have fun with those, and definitely give Kiro a try. It's been very helpful for us.
And thank you so much for listening to us. Hope you like this, and we are available outside the room for any questions.